This presentation and demonstration is for the client's first backup and disaster recovery solutions powered by Datto. Let's start with an overview of what backup and recovery really is about and what problems it solves. 70% of all businesses that typically would suffer a loss of data or access to their data for more than 2 weeks due to some kind of outage to primary business systems have been shown that they are out of business in less than 2 years. This is a survey done by Symantec. Only about half of SMBs, or small and mid-sized businesses, have a true disaster recovery plan. And that usually was created after some type of disaster occurred and the company found themselves not prepared. Only 28% have actually tested that plan. Now, why typically doesn't a smaller business have a disaster recovery plan? A lack of resources has been shown, lack of qualified staff, the data protection is not considered a priority, classic situation of the barn doors. It never really occurred to them and they don't view their computer systems as critical. But what are some of the top reasons for downtime? And in 2011, the average small business had 6 outages in a given year. Cyber attacks, i.e. viruses and other issues, power outages, hardware failure, something as simple as a hard drive or power supply or router, or natural disaster like hurricanes and the like. Downtime is extremely expensive and companies may not realize how much money is lost. An average small business loses $12,500 per day of time not having access to their systems. 44% of companies surveyed had one of their vendors temporarily shut down due to computer issues in a given year. And an overwhelming 54% of companies have switched at least one vendor due to the vendor's unreliable computer systems. Of those small businesses that do back up, the issues are as follows. First of all, about half only back up 60% of their data, and in many cases they don't even realize that. Less than half back up weekly or more frequently. Only 23% of those back up daily. 31% don't back up their email systems. 21% don't back up their applications and operating systems, and 17% don't back up their customer data. Tape backup was very popular and is still very commonly used, but it has a lot of problems. Failure rates among tape range between 41 and 72% when trying to restore data for a variety of technical reasons. Tape need to be stored in a very media-sensitive area in terms of humidity and temperature. It's very complex keeping track of all the tapes, keeping them in the right order, and if you lose one tape in a sequence, the entire backup is of no use. Tapes are very slow to retrieve data. They're okay to restore an entire server, but to fix or replace individual files, the tapes have to be scanned in order to find the components needed. And tapes can be notoriously slow in terms of how quickly they back up a system. So what's your plan? First, you need to have some strategic considerations. How will you continue operating if you have a temporary outage, a data loss, or a complete failure of all your IT systems, such as a lightning strike or a hurricane? What elements of your IT systems are most critical to you? Email, documents, your ERP or accounting system, your customer relationship management system, or other applications and portals you might be running. And why a backup solution is not always good enough. What many people don't realize, and they find out the very hard way, is it can take almost a month to restore your normal business to fully operational if you're using a simple backup solution. Now, it doesn't always take that long, but it can still take at least a week or two. Some of the reasons: if your servers were physically damaged or destroyed and you have to order replacement servers, it can take 2 to even 4 weeks to replace that hardware because almost all servers are built to order. And if there's a large-scale disaster and you're just one victim of many, the backlog with the vendors tends to become longer. If you're using tapes, can you even find a tape drive to replace the one that was destroyed? Do you have the software available to do a restoration, and it being the same version that may have been updated on your machines? Was your old tape drive out of alignment? If it was, putting out of alignment tapes in a new drive won't be readable. You might have a reliable backup solution today, but were your drives or tapes being taken off-site regularly? Or did the process kind of get lazy and maybe it was going out once a week or once every couple of weeks? Could you afford to lose the last week, 2 or 3 of all your data entry and transactions? It can take a day to as much as a week or more to restore your servers from backup data. If your current servers are physical and not virtual servers, the new servers you order are going to have different hardware than your old servers, and that requires that you can't usually just simply restore your old server image. You have to reinstall the operating system, reinstall all of the patches, all of your applications, all of your networking configuration, and then start the restore process of your data. Very, very time-consuming process depending on how many applications, how much data, and the like. And it can take a day to as much as a week to get your systems completely back to a functioning state because of this. And if this was a major disaster, most people who depend on an outside IT service technician, that technician will be juggling a lot of clients who are all affected at the same time and may be overwhelmed in terms of how quickly they can get to you. Are you willing to bet your business that your tapes and drives contain all the data that you deem important, considering that studies show that 60%, in many cases only 60% of your data is truly being backed up? So as you can see, there's a lot of things that can go wrong. And you really want to find out that problem when you really need to, in a disaster, get back up and running. So what if you already have an inexpensive cloud backup solution like a Carbonite, which is, can be very low cost, although they tend to cost more than you might think for a business situation. Well, first of all, you still have the same problem that if you had a significant damage to your servers or natural disaster, it'll take you 2 to 4 weeks to get your hardware replaced. So your data sitting up at Carbonite or any other cloud backup service doesn't do you any good in terms of getting back to operations until you get your new hardware. Then, like tapes, you have to manually reinstall your operating systems, then install Carbonite, then start downloading your data, then go through the restore process and manually address any hardware differences. Again, easily a grand total of 2 to 4 weeks before your server is back up and operational to your staff. A business can easily have over 1 terabyte of data total storage when taking into account all of your data, your operating systems, your applications. A typical internet connection can take over 70 days to transfer that much data back. In addition, your initial backup can take so long in the first place that it may not even have been completed by the time you need it. We've seen people where it takes over 3 months to get their entire network from their offices up to Carbonite. And this is because Carbonite and many others, in order to keep costs low, throttle your bandwidth even if it's slower than what you're able to send your data. Some of the vendors will, for an extra significant fee, ship you a hard drive with your data in case of disaster, a fee. But they're also known to have very small staffs, and sometimes it takes 3, 4, 7 days for them to get your data off of the cloud data center and have it shipped to you. They are not designed for overnight emergency scenarios. And then you still have your 2-week wait to get your hardware and your reinstallation. So, what's the solution to all these horror stories, which again sound like you have anywhere from a 2 to 4 week downtime after a complete hardware failure? The client's first backup and disaster recovery system is a hybrid cloud solution. What it does, and we'll just go ahead and just bring up a very simple illustration of this. What it does is it basically, your computers and users have their data saved on your local file servers. Your local file server then, on a regularly scheduled basis, typically every 15 minutes to an hour, automatically replicates its data to an appliance or a device that's in your location connected to your network. This is the BDR, or Backup Disaster Recovery device. This device then, on a daily basis, is uploading various versions of these snapshots to a secure data center, in our case in Pennsylvania. And that data center, in near real time, synchronizes its data to another data center in Colorado, so that even if the entire East Coast went down, you would still have access to your data. But what also significantly differentiates this solution from traditional backup is, number one, your data is contained locally, so if your building wasn't destroyed and you just had a significant server failure, you have your data available to restore it to another server. However, if your building was destroyed and your backup device was destroyed, you're able to fail over to the cloud. This backup device is more than just backing up, though. It is also, in the background, virtualizing your server, whether your server was physical or virtual in the first place. So this backup device at any time can be spun up as a clone of your down server, so that your users within minutes can think that they're talking to this server which is down, but it's really running virtually inside of this device. And that's how they're able to provide you with a real-time failover or near real-time, such that if your server went down, you're able to bring your servers back up and access them within minutes. If your entire facility was destroyed, you can then spin up a clone of your server in the cloud data center, and your users via the internet would be able to access your network servers via the internet and be able to operate as if they were on premise. Then, after the weeks have gone by that you've gotten your new hardware, they will overnight a device to you, which will then be used to restore your device. And any devices that are destroyed are automatically replaced at no charge. This scenario, you would do this restoration on a weekend or what have you, so as to have virtually no downtime to your users. This allows you to have the peace of mind to know that you would generally never have, even in a complete disaster, more than a half hour to an hour of downtime. And in a traditional just server down or hardware failure, you'd only be down a few minutes, failing over to your local device. So that's what we're describing here. And the data is backed up both to your local device and to the data center in the most secure fashion available, with the highest levels of 256-bit encryption. The data at these data centers is certified for government use, as well as HIPAA and other medical and compliance requirements. In addition, the device deduplicates and compresses your data, giving you anywhere from a 3:1 to 5:1 compression ratio, because many of your servers have the same kinds of files stored across multiple devices, and the backup appliance is able to only keep one copy of those files, and to the end user you don't know the fact that it's doing that. Some of the advanced feature is that every copy or backup it makes is actually, from the perspective of you, a complete snapshot of your server. The hardware environment, the software environment, all of the installed applications, and it's completely bootable. When you need to restore to your new hardware, there's a completely automated process that will re-inject your backed up server into your new live server, whether it's a virtual server or physical, and it will address almost all hardware discrepancies. In addition, as we mentioned, it makes both on-site and off-site virtualizations available. On a user-defined frequency, typically once per day, your backups are automatically booted up virtually in an isolated network, and a screenshot is taken. The system determines if the screenshot stops at a viable boot screen, where it would typically say hit Control-Alt-Delete to log on, and it stores a copy of that in the logs and can email it to you, so that you can see every day that you have a backup that is completely intact and bootable. All of this is done automatically. In addition, the solution comes with message level exchange and SharePoint recovery. So if a user just simply accidentally deletes a critical email message or deletes an entire folder, you don't have to restore your entire Exchange folder and losing all the data that changed. You can simply extract the data or the emails or the folders you need from one of the backups and restore it into your live production Exchange environment. The system comes in two affordable options. One is for those that don't want the ability to virtualize, and that's our G series. And that basically is a backup appliance. It backs up your data locally, and the local data is backed up off-site, ranging from as small as a 250 gigabyte unit to a 10 terabyte unit. This does not provide that ability to fail over, but it does provide a much faster way to restore your data as needed than a typical cloud-only solution. The solution we've been talking about, the Cirrus solution, is really the one that we highly recommend, and that's the one that does fully automated local and off-site backup, instant local and instant off-site virtualization of your servers in case your live servers go down, verification of your backups via a screenshot of the boot screen, full remote management of the entire solution via the web. Both your internal IT and we at Clients First can manage your devices and keep an eye on everything, making sure they're working. And you can buy the unit as small as 500 gigabytes all the way up to 40 terabytes of storage. It only takes 10 to 20 minutes to set the system up, depending on how many servers and training. It has powerful scheduling flexibility so that it can take hourly or 15-minute backups, but after a week start collapsing those into, say, daily backups, and then after months into weekly backups, so that you can go back to any version of your servers going back months or even years without it taking up a huge amount of space. And the patented Shadow Snap agent it uses is able to ensure that all of your in-use applications, whether it's your accounting systems, your SQL databases, your Exchange server, are in use. It's able to make a safe, usable backup of the data even though people are using the system at the time. So that's our presentation about the backup and why we think the solution is important. So we'll go ahead and log into the backup device from the console. Typically you have a username and password. And once you log into your local device, and this can be accessed both in your building or anywhere remotely. So as you can see, in our situation we have about 8 or 9 different servers all being backed up. Each one of these are being backed up approximately every hour during business hours. So our Exchange server, if we go in here, is scheduled to back up, if we go into our options, roughly every hour and then one time during the night. You can set this frequency up as often as you want to whatever works for you. It's automatically designed to take this inter-day backups and after a week convert them into one backup per day, and after 4 weeks turn them into one backup per week. There's numerous other options and settings, but that just gives you an idea. So when we look at this, we have these various backups. Now we're going to focus on one particular test server we have for use of demonstrating this. This is our test Windows 2008 server here. We are now booted into that server. That's the particular machine we're on here. And you can see this is a perfectly working machine. It doesn't have a whole lot running on it for test purposes, but it does work. We can do various things. Now this particular machine happens to be running in VMware virtual. This machine could be physical just as easily. You really don't know the difference. So we'll go ahead and minimize that at the moment, and we're going to manually go ahead and take a backup of that machine even though there's a schedule for it on the hour. To do that, we just simply say start a backup. Now the system says starting backup, and it goes through its backup process. After your initial backup, each backup tends to be very quick because it automatically detects all of the changed data as it occurs. And due to the advanced Shadow Snap technology, it doesn't have to scan the hard drive every time you make a backup looking to see what's changed. It's monitoring the drive as it's writing so that when it does its backup, it's very quick and has very low load on your actual server. After it goes ahead and finds what's changed from your last backup, it also injects the necessary drivers so that the machine can be booted up and set up so that it can be used in a virtual environment and have all the necessary components to operate. Goes through some other functions, and as soon as it's done, it's now deduplicating this to make sure that it's not storing the same data over and over. And we'll let it run. It's now doing a hardware independent restore, and it's done. The whole process took what? Probably less than 30 seconds to make a backup. Again, that is a smaller device, but our typical backups only take a couple of minutes even on high volume devices like our Exchange server. If we want to see all the backups available, we can click on Access Recovery Points. This is every backup that's been made, and they have different icons telling us. The backup this is designed that the midnight backup that's made to automatically get replicated off-site once a day. We can do that replication more often if we want, but for this server, once a day is good enough. We can also see that that backup had a screenshot made, and if we click on it, we can see that that backup image that was sent off-site is able to properly boot to a login screen so that we're able to know that this backup is good. If I had any question about that, I could actually manually tell it to take a screenshot, and now in the background the system is going to boot that machine up, take the screenshot, and post it on here, and if it's set up, automatically email a copy of that as well. So we're going to go into the machine and go ahead and just do something like change the background color. So we'll go to the display setting here, and we'll change the background color, let's say from blue to brown, just to give you an idea that we've made a change. And we'll even go ahead and create a WordPad document. And we will save it. And we'll save a copy in the documents. And we'll also save a copy on the desktop, just so we'll be able to see it. So you now see there's a copy of this document on your desktop as well. So we're going to go back to the backup device, and we're going to go ahead and spool up a virtualized copy of that server. So if we go into our local virtualization tab here, and we find the server that we're talking about, which is our test server, I can now spool up any version of that server. So we'll go ahead and bring up this last version from, I don't know, say 9 o'clock this morning. And from a networking perspective, we have different options. We could bring it up as a live server on our network. We can bring it up in a subnet so that the different servers can see each other, or we'll just bring it up completely disconnected from anything so that it couldn't possibly have any conflict with any of our live servers at the moment. So we'll go ahead and say start that virtual machine. And you can see very quickly it brings it up. And now the machine is in the process of booting. Now we can right from here automatically connect to it via remote desktop. So if we click on that, it creates a remote desktop link, and we'll go ahead and say connect. And you can see the machine is in the virtual copy of that machine is in the process of booting. Once it boots, we just press Control-Alt-Delete to log on, or now we'll go ahead and enter our password for this machine. And log in. So now you see we're logged in, and the machine is fully functional just as you saw it before. But you'll notice it has the old blue background. There's no document on here because this is a virtual copy of the machine before we made the changes. So now we'll just go back up. We'll go ahead and just log off of this, and we'll tell the system to stop and unmount the image. That basically means undo everything we just did, and it unmounts it and destroys any changes we made. Obviously we would use other options if we wanted to keep our changes. So now let's go back to it, and we'll make a new backup of the machine after the changes we made to the desktop and adding a file. So we'll go back to the test machine and we'll say start a backup. While it's doing that backup, let's also go ahead and see if that screenshot had finished from before. So this icon here means it was able to boot the machine okay, and here is a copy of it. So you can see you can do that at any time. So we'll go back to the screen, and we'll just pause while it makes the backup. So the system has finished making the backup. It took less than a minute, and if we look in the access recovery points, we'll be able to see that it took one, which is currently 10:34 a.m. Now we can do a number of things with this. We can export the image here to what's called a VHD or a VMDK. A VHD is typically used by Microsoft's own Hyper-V, and VMDKs are typically used by VMware. We can also do what's called a bare metal restore, in which we hook a cable up from the appliance to a new server or the existing server, and the system will push out this backup image into that server, automatically finding the necessary hardware drivers so that that server is now back to the state it was backed up in here. We can also delete these images. Now, this is an interesting concept. This device uses something called inverse chain backup technology, which in English means every one of these images are fully usable images, but unlike the old days where if you backed up, or excuse me, if you deleted one of your incrementals from your chain, then nothing after it would be functional. So I could take any one of these snapshots and say delete, and you'd say, are you sure? And almost instantly it deletes that backup, and yet all of the backups made from that point are all fully functional. They do not depend on the backup before it, yet any one of these can be booted up or restored. So in this case, we're going to go ahead and run that backup. So we're going to go, or rather run that image. So we're going to go to our local virtualization tab here, go back to our test machine, and this time we're going to start our latest virtual machine, or I could specifically pick it from here if I wanted to. So we'll just say start the latest virtual machine, and it's now setting it up and getting ready to boot it. You can again see that the process is quite quick. So under the hood, it's putting all the pieces together necessary for that machine to be ready to run. And now the machine is in the process of booting. And if we want to see what's going on, again, we can connect to it via remote desktop. And you can see it's in the process of booting here. So we'll put our password in. And we're at our desktop. Notice this desktop is brown and has our new document that we had added at that time, showing you how it's a different snapshot. So we'll just go ahead and close that at the moment. We can also unmount this image and essentially act as if we never started up that machine. And we'll go back to our backup agents, as we call it. Go back to the test machine and just show one other function here, and that is in these recovery points we can say go ahead and do a file restore. And now the system has made it where anybody on the network with the right credentials can go ahead and click on this link and browse it in their Windows Explorer, or you can go to a web browser view of it and look through your various directories here if you'd like. So we can go to our documents, go to administrator, go to our desktop, and you'll see our test document here, at which point we can open it up, save it, do whatever we want. So as you can see, this is just a high-level overview of the system, but it's quite comprehensive. It's always monitoring everything, giving you reporting, alerting options, status views, showing you what you have here and what is off-site, each of your servers, if they're in the process of synchronizing off-site or if they're fully synchronized according to your schedule, how often you want to synchronize off-site. We also have the ability to throttle the network bandwidth so that the system doesn't slow your internet down during business hours doing its backups, but yet after business hours can speed up or use up all of your bandwidth depending on your options. So thank you very much, and please feel free to call or email us if you have any questions about the device.